Hello everybody, welcome to lecture 0 of our astronomy class. And before we really dig into learning some of the details of astronomy, I like to start with just an overview of the solar system in general so that we all know the basics before we get going. First of all, let's just review the first 8 planets in the solar system, or not the first 8 planets, the 8 planets. Now we all know that Pluto used to be a planet and is not considered a planet anymore. We'll go through why that is the case later on in class. But just remember the 8 planets: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. I know it's simple, but hey, not everybody might know it. Just get it down on paper. That way we've got it. Those are the 8 planets. Let's start talking about probably the most important thing in the solar system. Now, of course, you're thinking, hey, Earth is the most important object in the solar system. That's true, because we're here. If the Earth wasn't here, we wouldn't, nobody would care, right? about the solar system. At least nobody on Earth. But the sun is the center of the solar system. It's the largest object. It's the object that all the objects in the solar system are orbiting. So anyway, here's the sun. Here's a nice little relatively close-up picture of the sun. The diameter of the sun, now remember the diameter is the distance all the way across, is 865,000 miles. Now we will prefer to use metric units in this class, SI units. That works out to be about 1.4 million kilometers. Later on, we'll just use kilometers instead of miles. If you're wondering, how do you get a hold of some distance like that? Well, the Earth, picture how big the Earth is. It's about 8,000 miles across. The diameter of the Earth is 8,000 miles. And it turns out then that the sun is 109 Earths across. You could put 109 Earths across the diameter of the sun. So the sun is very, very big. It's huge. The Earth is big in our everyday experience. The sun is way bigger than that. Here's an even closer up picture of the sun. This is a sunspot you see there. This is the surface of the sun. It's rather granular. It kind of looks like if you've ever seen a corn on the cob with the corn kernels there. Kind of looks like that, these granulations. We'll talk later in class, in the solar system class, about why that's the case. This is a sunspot, which is a little depression, a little storm, a little magnetic storm that pushes down against the surface, and it's a little bit cooler there. That's why it appears to be dark. Okay, and then just for kind of getting our feet wet in the sun, this is the sun. There are actually 6 layers to the sun. Way down inside, there's the core. That's where the energy is produced in the sun, nuclear fusion, which is 4 atoms of hydrogen fusing together to become helium and releasing some energy. That's where the sun gets its energy from. And then there are 2 other layers above that inside of the surface of the sun, the radiative zone, the convective zone. And then the surface of the sun, if you want to think of a surface, is where the light is released. That's called the photosphere. And then there are 2 layers above that, the chromosphere and then the corona. Now, you don't have to know any of that yet. That's just kind of an introduction of things to come. All right, moving on from the sun, the planet Mercury. Now, this is a picture of the planet Mercury. Now, if I just showed that to you, what object does that remind you a lot of? Right? It looks a lot like the moon, right? Planet Mercury is just a little bit bigger than the moon. You'll notice actually it doesn't have as many craters. Now, it's not really that it doesn't have as many craters. It's just that it's a lot more dense. The rock is a lot more stronger than the moon. So the craters that are there just aren't as big. So there are a lot of craters on Mercury. It's just Mercury is very, very dense. So the craters just aren't as big. But you can see some big craters there. Mercury is the smallest planet. If we're not talking about Pluto, not as a planet anymore, then Mercury is the smallest planet, closest to the sun. From Earth's perspective, if you look at it through a telescope, you see that it goes through phases, kind of like the moon goes through phases. And we'll talk later in class about how that's a big part of showing that solar system objects orbit the sun, not the Earth. If you look close up, you can see a lot of those craters. All right, the second planet, Venus. There it is. Now, Venus is just a little bit smaller than the Earth, just a little bit less massive than the Earth, but unfortunately quite a bit different from the Earth. Completely covered in a very, very thick atmosphere. As a matter of fact, if you went to the bottom of the Earth's ocean, the deepest part of the Earth's ocean, you know that as you go farther and farther down inside of the ocean, the pressure gets higher and higher and higher. If you went to the deepest part of the Earth's ocean and measured the pressure and compared it to Venus, nowhere close. Venus way more dense than that. Venus has a very, very thick, very, very dense atmosphere. If you somehow got to the surface of Venus, you would just squash like a bug in a second. I mean, oppressive pressure. Very, very hot. 860 degrees Fahrenheit. 860 degrees Fahrenheit. The cloud layers are so thick, there's actually sulfuric acid clouds, and so it rains sulfuric acid on Venus. Yes, a very, very nice place. That atmosphere is so thick and those clouds are so opaque that you cannot see the surface at all. Okay, though that's highly reflective. The light that hits it bounces off, and so it appears very, very bright in our sky. You can put radar signals through that atmosphere. So we've sent space probes that have mapped the surface of Venus, not by looking at it with visible light, but with radar, with radio waves. And so this is a kind of a picture of that map. You can see Venus actually has, more than likely they're extinct volcanoes, but they're very, very huge. And since there's so high of a pressure and so hot, all those volcanoes made rivers of lava that just flowed for thousands of miles across Venus. See these white streaks? Those are actually lava beds. Like I said, once again, it's thought that these volcanoes and these lava beds are now cool, and they're not active anymore. But rivers of lava went on for thousands of miles. All right, anyway, so that's just a brief overview of Venus. Now this is Earth. Here's Earth from space. There's Earth at night. You can see the United States there lit up with all the lights. Let's see. I used to see. There's St. Louis. There's Kansas City. I think one of these. I think that's Wichita. I think that's Topeka right there. Anyway, from space, we don't really talk about Earth that much in this class, just because we're talking about astronomy, and I let the geologists or something like that talk a little bit more about Earth. But we'll just talk about Earth just enough to be able to talk about the other planets. But it's the third planet from the sun. Number 4, Mars. Now, Mars always captures the imagination. Right? It's actually, other than the Earth, it's the spacecraft that's been most visited by us so far. We've sent dozens of spacecraft to go there. Mars is about half the size of the Earth. Here's the Earth, there's Mars. It's about half the size of the Earth, but actually by mass, it's actually quite a bit smaller. It's only 10% as massive as the Earth. It has 2 moons. Now Mars, Roman name for the Greek god of war. Okay, his wife was actually Venus, the goddess of beauty. I don't know if you knew that or not. The god of war and the goddess of beauty. They had 2 children. Their names were Fear and Terror, Phobos and Deimos. And it turns out that Mars has 2 moons. So they named them after the 2 suns, Phobos and Deimos. There they are right there. Now, they're not moons in the traditional sense. They're probably just captured asteroids, but still there they are. Here, if we can see a picture of Mars, you can see that Mars has ice caps, a lot like the Earth does. Now, it's mostly frozen carbon dioxide, but in the northern ice cap, they have found frozen water. And so there is frozen water on Mars. You can see there's clouds in the atmosphere right there. And if you look closer, in this picture, you can see the craters down there. And so you can still see a lot of those craters on Mars. All right, more on Mars later in class. If you're in the solar system class, certainly. All right, Jupiter. Jupiter, the largest planet in the solar system, named for the head of the Greek and Roman gods, Zeus. There it is, largest planet. Let's see what to say. You know, Jupiter isn't just the biggest planet. It's biggest by far. If you took all the other planets, Mercury, Venus, Earth, Mars, Saturn, Uranus, Neptune, plus all the other stuff in the solar system. Now, I'm not talking about the sun, but all the other objects, asteroids, comets, whatever else, dwarf planets. Take all of that, add them all together, double it. Jupiter is still bigger than that. So Jupiter just isn't bigger than all the other planets. It's way bigger than all the planets. Jupiter has 4 moons. Okay, 4 moons. From closest in to farthest out, Io, Europa, Ganymede, Callisto. Ganymede is the largest moon in the solar system. Bigger, actually, than Mercury. Ganymede is bigger than Mercury. Has a very, very strong magnetic field. There are aurora there, captured in picture form above the poles of Jupiter. There's a moon backlit against the equatorial bands of Jupiter. By the way, you see that little blue spot there? This is Io. It's actually a volcano erupting on Io. And then this is kind of you can see that Mars, or why do I keep saying Mars? Jupiter has tenuous rings. Okay, so it turns out all the gas giants, Jupiter, Saturn, Uranus, Neptune, have rings. And there they are. There's the rings of Jupiter. Let's go on. What's after Jupiter? Saturn. Lovely planet with the rings, famous for its rings. Galileo is the first one who saw the rings, even though he really didn't know what it was he was looking at. When he saw them through his telescope, he thought that, he wrote in his log when he was recording this, he said, Saturn has ears. Anyway, there it is. There's the equatorial bands in the atmosphere, just like Jupiter, the lovely rings. There are the rings backlit, so you're out past Saturn. The sun is actually in the spot there where Saturn is. And it highlights those rings. They really stand out. It has aurora, has a very powerful magnetic field, just like Jupiter. All kinds of moons out there. Actually, Saturn has more moons than Jupiter, including the moon Titan. Titan is the only moon in the solar system that has a thick atmosphere. And by the way, you know, we kind of think that Earth is the only place with water. Well, it might be the only place with liquid water on the surface, but actually all of these moons, now not Titan, but all these other moons, there's all kinds of water in there. Actually, Enceladus has water volcanoes, ice water volcanoes, and these rings, mostly frozen water ice. So there's water all over the place. It's just frozen out there in the distant part of the solar system. Uranus, you notice the distinct blue color, kind of a sky blue, right? Well, that's why it's called Uranus. Uranus was the Uranos. Uranus, it's the Greek god of the sky or heaven. So that's why it has that sky blue color. You can see Uranus there. About 4 times bigger in Earth by radius. Now by mass it's 14 times bigger. But by radius it's about 4 times bigger than the Earth, which is quite a bit bigger than the Earth, but actually nowhere near Saturn and Jupiter. Saturn and Jupiter are way bigger than the Earth. Anyway, you see there's the rings of Uranus. Now, it has cloud layers, even though when you look at it in true color, in visible light, you notice any equatorial bands. But when you look in infrared and ultraviolet, I believe this is an ultraviolet picture, you can see the cloud layers. So it has cloud layers, equatorial bands, just like Jupiter, just like Saturn. Plenty of moons. Uranus has all kinds of moons. There it is. Okay. Let's see. Let's move on then. The last planet in the solar system, Neptune, once again blue. Why blue? Why are Uranus and Neptune blue? Because it has methane in the atmosphere. And methane, you notice, now methane, natural gas, clear, but like when it burns, when it interacts with light, it's blue, right? If you think of like a furnace burning when it's burning in the winter, or if you have a kitchen stove that uses natural gas, when what's the color of the flame? It's blue, right? Well, that's the reason why Uranus and Neptune are blue, because they have plenty of methane in their upper atmosphere. Neptune, the Roman name for Poseidon, the Greek god of the ocean, and you see it's more of a dark blue than a sky blue. Just about the same size as Uranus as far as its radius. Has all kinds of clouds, interesting clouds. You can see some of the cloud equatorial banding. Okay, unlike Uranus, it stands out a little bit more. Now, Neptune does not have as many moons. As a matter of fact, it only has one big moon named Triton. Okay, known for its distinctive cantaloupe terrain. You ever seen a cantaloupe, the skin of a cantaloupe? That's kind of like what that terrain looks like on Neptune. Not really understood why that's the case, but there it is. It has a few other tiny moons, but Neptune only has one big moon. Once again, Neptune, last planet in the solar system. Now you go out past Neptune, and there's Pluto. This is an old Earth-based telescope picture of Pluto with its large moon Charon. This is a Hubble Space Telescope picture. There's Pluto and Charon. Pluto, Greek god of the underworld, right? And Charon was what? To cross into the underworld, you had to cross the river Styx. And Charon was kind of like the boatmaster. Okay? There it is. Now, for the longest time, this was the best photo that we had of Pluto. But in 2015, a spacecraft called New Horizons got there. And so this is an early photo from New Horizons on January the 30th, 2015 with its navigation camera, taking a picture of Pluto and Charon. Now, we've got better photos than this, but I just wanted to show you, there's that picture. This is before New Horizons got there. This is a photo showing the 5 known moons of Pluto. So there's Pluto, Charon, Styx, right? Named after the river. Kerberos, I think it was a 2-headed dog. Maybe it was 3, I forget. Involved in the story. And then there's Nyx and Hydra, which are Egyptian. Or, well, anyway, they're also related to that story. So Pluto has 5 moons. Just once again, just because you have moons doesn't make you a planet. Okay. Anyway, this is Pluto. Size comparison. There's Earth. There's the moon. Pluto is smaller than the Earth's moon. Now, the spacecraft New Horizons did get there, and this is probably the most famous photograph of Pluto taken by New Horizons. You can see it has this distinct, what people are calling the heart-shaped feature there. This Pluto, you can see some craters. You see this red dust. Okay, so down inside Pluto, there's a rocky core, there's some water ice, frozen nitrogen. So we've learned quite a bit about Pluto, but there's still plenty to learn. More to Pluto. It has an atmosphere, so this is a backlit photo. After New Horizons passed Pluto, the sun, once again, is in here, in the middle here, where Pluto would be, and the atmosphere gets backlit. So Pluto does have a very thin, tenuous atmosphere. There's Charon, the big moon. Now, Charon is a little bit more than half as big as Pluto. So, that's one of the reasons why Pluto is not considered a planet. It has this moon that's almost as big as it is. These are photos of the other moons, Styx, Nyx, Kerberos, and Hydra. And there we go. All right, now, Pluto is the largest example of what's called a Kuiper belt object. Kuiper being the astronomer who found this. And so it turns out out past Neptune, there is another asteroid belt, if you want to think of it. Another region where there are small objects, but instead of being rocky, they're mostly icy, frozen, somewhat rocky, but icy as well. Region of small objects out past Neptune. And Pluto is just the largest one of the largest examples. Turns out that there's all kinds of objects out there. Sometimes they're called trans-Neptunian objects out past Neptune. Okay, Eris, Haumea, Makemake, Orcus, Quaoar, Sedna, all kinds of things. And then just last year, in January 2019, the New Horizons space probe kept flying out past Pluto and flew by this object, which for a while was called Ultima Thule, but it got officially called Arrokoth. So you can see that it's actually two objects kind of stuck together. So there it is. Kuiper Belt objects. All right, now what else is in the solar system? Comets. Okay, comets are icy, rocky planetesimals, things left over from the early solar system. Some of them break down inside to the inner solar system and fly around the sun. Some of them kind of have orbits that keep them in close to the sun and they repeat. Others can only come through the solar system one time and go way back out to the far edges of the solar system. Okay, but anyway, there's an icy nucleus to a comet, and then as it gets closer into the sun heats up that nucleus of icy material, and it starts to become a gas, and that gas is often a greenish color, a bluish green color called cyan, C-Y-A-N, cyan, actually identified when Halley's Comet went through in 1917, 1918. People knew about cyanide gas, and they knew how to take spectra to determine what chemicals were present in gases. And by the way, we'll learn about spectra later on in class. But they knew about cyanide, and they discovered that comets had cyanide in them. And so that's what led to the comet craze, that comets might, I don't know, kill everybody on Earth. There was kind of a panic, a little small panic in 1917 that Comet Halley was gonna, I don't know, kill everybody on Earth as it got too close. But of course, there's nowhere near enough cyanide in there to do anything to the Earth. But anyway, there it is, cyanide. Sometimes a little bit of science knowledge doesn't do so much good. Can cause a little bit of panic. Anyway, comets have tails. Okay. By the way, coma, this greenish atmosphere. Bluish greenish atmosphere. Coma is the Greek word for hair, because oftentimes comets in the sky look like they have little strings coming off of them, tails, and so that's where that word comes from. It's the Greek word for hair. Anyway, comets have two tails when they get in closer to the sun. There's the ion tail and then the regular tail. There it is. Now, we have not had a good naked eye comet in the northern hemisphere in a long time. The last really good one was Hale-Bopp in 1997, which, depending upon how old you are, if you're the typical college age, that was before you were born. So most of you have never seen a comet with your eye just in the sky, and so you have no appreciation for how grand one can look. This is Hale-Bopp from 1997. You can see how big it is. It really fills up the sky. Way bigger than the moon. Way larger than the moon. 3 or 4 moons across, filling up the sky. It was thought for a while that in March 2013, Pan-STARRS was going to do that. Now, you could not, these are photos. So the photos, you can see the comet, but with your eye, you just could not see them. We have not had a naked eye comet in 23 years. Speaking of comets, comets have those tails. The material gets blown out of the comet as it gets heated up by the sun, and so it leaves a trail of particles. And then the Earth, as it's orbiting the sun, sometimes passes through the path of those comets, and that material enters the Earth's atmosphere and burns up, and that makes a meteor shower. So meteor showers are the dust from previous comet trails that, as the Earth runs through that old stuff, it burns up in our atmosphere and makes a meteor shower. So since they're from one spot in the sky where the comet used to be, where the trail used to be, the comet, a meteor shower appears to come from one spot, and so usually those are in the zodiac, and so they're named for whatever constellation the meteor shower appears to be in. So this is, for example, from August 12th, 2013, the Perseid meteor shower. And these are the meteors. You see these white streaks? The way this was recorded was someone just took a camera in a dark spot, pointed it to where they knew the meteor shower was going to be coming from, and opened the lens and turned on the camera, opened the exposure, and just let it sit there for 3 or 4 hours. And so you see all these streaks. These are the meteors. And you see, if you trace back where the meteors all come from, you see they all come from about right there. That point is called the radiant. That's the spot where that comet tail is and where all the meteors seem to be shooting from. All right. So anyway, meteor showers are comet dust that the Earth is interacting with. All right. Now there's also asteroids out there. Now the asteroid belt is mainly between Mars and Jupiter. You see, this is the inner solar system. There's the Sun, Mercury, Venus, Earth, Mars, and then this is Jupiter out here, further out. That's Jupiter. Okay, so this region right here, that's where asteroids are. Now, there are asteroids that actually cross the Earth's orbital path. And if they do that, if they cross our Earth's orbit, then Earth could theoretically crash into them. And so we want to know about those asteroids because we don't want Earth crashing into some asteroid and us be unprepared for that, because that tends to be a bad thing. So these are potentially dangerous asteroids near Earth. These are all the orbital tracks of all those objects. Now, I don't put these up here to scare you. I just put them up there for you to appreciate how many there are. And so actually that's one of the big projects of NASA right now, is to track all these things and to find all the ones so that we know what we're dealing with. There we go. All right, what else do we have here? Sunspots, just an even closer in picture. There's the sun. Whole region of sunspots. These sunspots are bigger than the Earth, just for the record. These are huge. All right. This is Saturn once again. Cassini was a space probe that for more than 10 years orbited Saturn. And we learned a lot about Saturn, about the rings, about all the moons of Saturn. Finally, it ran out of fuel and it was crashed into Saturn. So it's no longer orbiting Saturn. But in the process of doing that, it did take an interesting photo one time. This is Saturn backlit with all the rings. Okay, and that little blue spot right there, that turns out that is the Earth. Now, let me prove that to you. There's the rings. We zoom in. There it is. We zoom in even farther. You keep zooming in, and you notice, bam, you see this object popping out? There's the moon. So there's the Earth. There's the moon. Okay, so from Saturn, there's a picture of you, and there's a picture of the moon. All right, now, it isn't just that there are planets around our sun, our star. There are planets, it turns out, around pretty much every star that can possibly have planets. And so there's a lot of ways that astronomers detect planets. One way actually enables us to be able to take a picture of that planet. So this is a digitally altered photo. Actually, stars are so bright that you have to digitally remove the light from the star. And so that's where the star would be. Okay, and then this is a planet that has 5 times the mass of Jupiter. So it's 5 times bigger than Jupiter and orbiting that star. So if you were to keep taking photos of this, you would notice it orbiting that star. And by the way, this is 300 light years away. We'll define a light year later, but basically it's the distance light travels in 1 year. Over 10 trillion miles, so very far. But 300 light years is relatively close in astronomical terms. So there is actually a planet, a picture of a planet orbiting a star other than the sun. All right, so where do stars, how do they get developed? They develop in nebula. This is the famous Orion Nebula, which is a region where stars are forming. So there's a big collection of gas and dust. Gravity collapses it together. A little region starts gravitationally attracting to one another, starts to rotate, and a star and a solar system forms down inside of there. Way down inside, way down in here, there's it's called the trapezium. There's these 5 stars. Those are brand new stars that have formed deep inside the nebula. Okay, so nebulae just aren't beautiful. They're stellar nurseries. They're regions where stars are forming. This is 1,500 light years away. That's the Orion Nebula. Speaking of, where we're at, this is a picture of the Milky Way galaxy from the top of some mountain. Okay, the galaxy sweeps across the sky. Now, most of you, if you live anywhere near Topeka or a city, have never seen the Milky Way. So there it is, arcing across the sky. Up until Galileo looked at it through his telescope, no one had any idea that those hazy patches there were stars. They thought it was a cloud, some kind of quote unquote milk spilled across the sky. There it is. And the Milky Way isn't the only galaxy. We are orbited by 2 satellite galaxies. There's a lot of satellite galaxies, but the 2 biggest are the Large and Small Magellanic Clouds. Now, you've never seen them, more than likely, because you can only see them in the southern hemisphere. This is from an observatory down in Chile, South America, and so there is a picture of the night sky. There's the Large Magellanic Cloud, the Small Magellanic Cloud, named for Magellan, the first European that sailed around the world, right? Entered the southern hemisphere. So he recorded them for Europeans the first time. It's not that no one knew about them, it's just no European knew about them. So anyway, there's the Large Magellanic Cloud, the Small Magellanic Cloud. There's kind of a better picture of this large and the Small Magellanic Cloud. There's also a globular cluster right there in the same field of view as the Small Magellanic Cloud. Both clouds are intense star-forming regions, and so there's another nebula with the star-forming region right there. And finally, this is a picture of a typical galaxy. If you could draw away from the Milky Way galaxy, this is a lot like what the Milky Way galaxy would look like. This particular spiral galaxy is 100 million light years away. You can see other galaxies off in the distance. Kind of looks like a hurricane, right? That's what a spiral galaxy looks like from the top. You can see the spiral arms. There's the core down inside, as well as the halo and the other regions of the galaxy, star-forming regions, okay, the bulge and all of that. So anyway, that is the introduction to the solar system in general, and hope you were able to learn something. We'll talk to you later.